So, hi guys. So today we will be talking about Cauchy's method. So what is it? It's a method to find optimal solution to any given problem which is NLP in nature, non-linear programming. So we will see by looking at an example. Let's begin. Our question would be like this. I'll directly jump onto the question. So we will have to minimize f is equal to, that is function is equal to x1 minus x2 plus 2x1 x2 plus 2x1 square plus x2 square, starting from point x1 is equal to 0, 0. So these data will be given in the question. So from that we'll have to minimize this function. This function would be some like the graph would be like this, or something like that, we can assume, and it will have some maximum or minimum point provided that condition exists. So we have to like find the minimum point, that is this point. What is the x1 x2 for this case? So this is the R2 plane. So how will the solution look like? Let's let's see. Okay. So first of all, we will have to find the gradient of f. What is gradient of f? Gradient of f is like derivative of the function with respect to its corresponding variables for one case, like for one time only. So we'll differentiate this equation f with respect to x1. We will get df by dx1, that is this function with respect to x1. So the terms would be 1 minus 0, that I will omit it. This one would be 2x2. This would be 4x1. And for the second case, it would be minus 1 plus 2. This one would be x1 plus this one would be 2x2. This term would be 0 with respect to x2. This is the grad f that we found, and substituting the starting point, that is 0, 0, that x1 is equal to 0 and x2 is equal to 0, we will get grad f is equal to 1 minus 1. Now the important part of the solution, that is search direction. We will have to find that search direction in order to proceed with the step, and it would be like minus of grad f1 for that Cauchy method. Okay, why minus? Because we have to minimize the function. Suppose it was given we have to maximize this, then we can proceed with s1 is equal to plus f plus grad f. Since it's a minimization problem, we will go with minus grad f. So just multiply by minus 1 into this matrix, we will have minus 1 into 1. Clear? Easy. And this would be the small variables s1 and s2. Okay. Next page. So what is x2? X2 is the second variable, and it is given by the formula x1 plus minus of grad f1. Why minus? Because this is a minimization problem. If it would have been maximization problem, we would have written x2 is equal to x1 plus grad f1. Okay. Into lambda star, of course. Yes. What is lambda star? Lambda star is the step length. And what was s? S was the search direction. So we have the x1 as given in the question. You can see this thing, x1 is equal to 0, 0. So substitute that into this, we will have 0, 0 plus, I will write this lambda star here, into minus grad f1. What is minus grad f1? Minus grad f1 is minus 1, 1 into minus 1, 1. This is minus lambda star and plus lambda star. Okay. Then substitute this x2 into the function, that is function of x2. the same x2 value. And x2, what is x2? x2 is minus lambda star and lambda star. Okay. Now, so what was f? F we have written, f was this function value. Let me write this here, is equal to x1 minus x2 plus 2x1 square minus 2x1 x2 plus x2 square. Okay. Substitute this x2 value into this x2. We'll have x1, that is minus lambda star. We'll write minus lambda here only for that, for just writing it easy. Minus, substitute this lambda plus 2 into x1 star. x1 square is minus lambda square, that is lambda square, plus 2x1 x2 plus 2 into x1 into x2 lambda plus x2 square. What is x2 square? Lambda star square, that is lambda square. This is f of x2. Substituting and solving, we'll have fx2 is equal to, directly we can write 2 lambda square minus 2 lambda square. This get cancelled. This term remains. This would be lambda square minus 2 lambda. These two terms. Now, just differentiate this fx2 with respect to lambda. That is df by d lambda is equal to 0. We have to proceed by this step. So differentiating this fx2 with respect to lambda, we will get 2 lambda minus 2 is equal to 0. From that, our lambda star value comes out to be, we will, okay, let me write one more step. 2 lambda is equal to 2, lambda is equal to 1, lambda star is 1. Okay. So what have we found? We have found lambda star, and we will substitute this lambda star to this equation. That is x2. It will give x2 is equal to minus lambda star lambda star. That is minus 1 and 1. Go to the next page. So substituting x2 value minus lambda star, it would be, because lambda was 1, minus 1 and 1. Now, so x2 is known. Now we'll go to the second iteration. This was the first iteration that we did from here, from this part, iteration 1. Like what we do in iteration is the repetitive steps that we follow to get an answer. So from this iteration, we have found the grad f1 value, the search direction 1 value, and lambda star and x2 from this iteration 1. Same, we'll do the same process. We will write x3 is equal to x2 plus another lambda star, that is lambda 2 star into minus of grad f2. Okay. Why minus? Because we have to minimize the problem. So what was our x2 from, as we have calculated from this process, we will get minus 1 1 plus lambda 2 star is unknown into minus grad f2. What is minus grad f2? We'll check. Okay, we have not calculated it. We'll do it here. Grad f2 is the value of that gradient at x2 point, that is minus 1 and 1. What was our graph f? Grad f is this 1 plus 2x2 plus 4x1. So we will substitute this grad f at second point, which is minus 1 1. Yeah, minus 1 1. So we'll get 1 plus 2 into this second number, because this is 2x2. 1 plus 2 into 1, that is 2, and 4 into minus 1, minus 4. And for this, the second term, it is minus 1 plus 2 into x1 is minus 1 we'll get minus here. I'll do this. -1 -2 plus 2 into this term plus 1 plus 2. This is our grad f2. Grad f2 will solve, we'll get 1 plus 2, 3 minus 4 minus 1, and these two terms will get cancelled. This will remain -1. So our grad f is f2 is -1 1. Okay, so we'll substitute this here. So let me write it this way. This minus term will remain, let's say -1 into what is grad f2? We just now calculated -1 1, -1 -1. So this would be -1 1 plus -1 into this -1. It will be +1 +1. It would be 1 1 column matrix with lambda2 multiplier. That is lambda2 lambda2. This is our x3 value. And write in this way 2 -1 plus lambda2 1 plus lambda2. So our x3 now is formed. So we'll do the same process that we have done in the last process, that we will substitute the x3 functional value into the expression itself. So what was the expression? Expression was this: x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square. So in place of x1, we will write -1 plus lambda2, and in place of x2, these three parts, we will write 1 plus lambda2. So when we will substitute, we will have, just let me write it. So fx3 would be like x1 minus x2 plus 2x1 x2 plus 2x1 square plus 2 plus x2 square at what? At x1 is equal to -1 plus lambda2, x2 is equal to 1 plus lambda2. So when we will substitute these two values into this equation, we will have fx3 is equal to, we'll have of course we will get some quadratic function in terms of lambda2. So we will have 5 lambda2 square minus 2 lambda2 minus 1. So you can check it, like let me like give you a homework, like you should try it on your own to get this value of fx3 is equal to this function. You should match it with it. It should match. So again, like we have to do the same step. We have to find the derivative with respect to lambda2. So it would be 5 to the 10 lambda2 minus 2 is equal to this f dash x3. Now we'll substitute this f dash x3 value to 0 to get that in the next page. F dash x3 is equal to 0 to get lambda2 star value. So when you will calculate, it will be 10 lambda2 is equal to 2, so lambda2 is equal to 2 by 10, that is 1 by 5. Okay. So we have now calculated lambda2 star. From that we can calculate x3. How x3? Like from this equation, x is equal to this plus this, or like x3 is equal to -1 plus lambda2, 1 plus lambda2. So when you will substitute -1 plus lambda2, that's -1 plus 1 by 5, that is 4 by 5, and 1 plus 1 by 5, that is 6 by 5. x3 is known, these things are known. So now what we'll do in Cauchy's theorem, the basic aim is to find this grad f value at that, or at all these iterations, like for x1, for x2, for x3. So for the third, for the del f3 value, grad f3 value. So as I have told you, it is the value of this gradient of function at x3 point, these two values. So we know this grad f value that we have calculated. It is 1 plus 2x2 plus 4x1 minus 1 plus 2x1 plus 2x2. So in place of x1 and x2, we will substitute these two values. So what we'll get, you should try, you will get like 0.2 and minus 0. Just a substitution, it's mere substitution. So until second iteration, our part is complete. So what is our aim? So our aim is to like minimize the function, like find these x1 and x2 values. So how it will be minimized? It would be minimized corresponding to that point its gradient of f should approach 0. Yes. Like we have studied, yes, like you can, as you have studied in your earlier classes, like for let's say for some curve, there is some extremum point. And for this extreme point, this at this point this slope value, that is dy by dx, is 0. So the same thing that in this multivariable case, let us we should approach 0, which is not happened, which has not happened here. So what we'll do, we will continue to iteration 3 and all until we get CADA is equal to 0. For examination point of view, I think this iteration until iteration 2, the part is complete. So that's all for the video. Thank you.